So friends, in this video, let us try to solve this problem where we have a disk of radius 5 meters and its weight is 10 kg, and the disk accelerates from the rest to 30 radians per second in 6 seconds. So what we have to find is what is the work done. So work done is basically can be given by change in rotational energy. So disk is not making linear motion, it is just doing a rotational motion, okay? And that's why we don't have to consider the kinetic energy because of linear motion. We have to just consider the kinetic energy due to rotational motion. So let us call it rotational energy. So if you find the change in the rotational energy, then we will be able to find the work done. So basically, we will have to find the rotational energy, final rotational energy, and then subtract it from the initial rotational energy. So for the disk whose radius r, mass m, the rotational energy is given by I 1/2 I omega square. So that will be the final angular velocity minus 1/2 I omega initial angular velocity. So we know that the initial angular velocity is 0 because initially the disk was at rest. So this term will be 0. So we have to just calculate this thing now. 1/2. Now I is the moment of inertia for the disk, which is rotating around the axis which is at the center. So that moment of inertia is given by 1/2 mr square and final angular velocity. So the final angular velocity given is 30 radians per second. So you can put that value 30 into 30. We know that the mass is 10 kg, radius is 5 meter. Yes, and this is the angular velocity. So it is gonna be 900. So let us solve this. 450. So it is gonna be 25 into 5 into 450, which is equals to 56 to joules. That is the total work done. So in this case, remember that the disk is not making linear motion. That's why we just consider the rotational energy. But if disk is making also the linear motion, that is it is rolling, then we will have to consider the kinetic energy due to the linear motion as well, 1/2 mv square. But in this case, it is just rotational kinetic energy. Now let us solve the same problem with a different technique. So we know that work is equal to force into displacement. Okay, this is for the linear displacement. But when we talk about the angular displacement, we have this formula. Work is equal to torque into angular displacement. So first of all, let us find the angular displacement, then let us find the torque, and then we will multiply those numbers. And the answer that we will get will be exactly same as we calculated it before. So let us calculate the angular displacement. So we can use the kinematic equation over here. So we know this formula, displacement is equal to 1/2 u plus vt. So that is speed into time, average speed into time will give you the displacement. But this is for the linear motion. Now for the rotational motion, we have equivalent formula which says theta, that is angular displacement is equal to 1/2 initial angular velocity omega, say let us call it omega I, plus final angular velocity, let us call it as omega f into t. So what they have given is initial angular velocity is 0, okay? Final angular velocity is given as 30 radians per second, right? 30 radians per second, and time is 6 seconds. So it took 6 seconds to go from rest to 30 radians per second. So this comes out to be 1590 radians. So total angular displacement is 90. Now we calculated this angular displacement. Let us calculate torque and then we can just multiply these numbers. So we know that force is equal to mass into acceleration. This is for the linear acceleration. Now if you want to find out the torque for the angular acceleration, we can find it as torque is equal to moment of inertia into angular acceleration alpha. Now we know the moment of inertia, that is 1 half mr square, and alpha is basically angular acceleration. We don't know this, but we can calculate that using this formula. Again, we can use kinematic equation. S is equal to ut plus 1 half at square, where s is the displacement. Now we know the angular displacement is 90 radians. So we are going to use the equation for the angular motion. So s is basically a theta. So 90 radians is equal to ut. Here u is the initial velocity. We have to consider initial angular velocity, which is 0. So this term will be 0 plus 1 half. Now a is basically alpha because we are considering angular motion. So it is angular acceleration. And t is the time. So time that they have given is 6 seconds. So we can put 6 into 6. So we can multiply divided by 3. So alpha is gonna be 90 divided by 18. So we can put that value over there. 90 divided by 18 is equal to 1 half. Mass is 10 kg. Radius is 6 meters. Sorry, radius is 5 meters. So into 90 divided by 18. So we can divide by 2 over here. This comes out to be 25 into 5 to 90 divided by 18. So that is the torque. Now work done will be torque into angular displacement. So it is going to be 25 into 25 into theta. That is 90 radians because that is the angular displacement, 90 radians. So if you calculate this, it should come out to be 56,250 to 6,250 joules. That's it. So there are two ways in which you can calculate this particular value. Thank you for watching.